In your last class, you had a good review of area and perimeter, and in this lesson, you're going to have a good review of perimeter word problems. We're going to take area and perimeter word problems. We're going to take what we learned from the last class and apply that to some word problems that involve finding the area and perimeter of specific shapes. And it's important to remember that area is the square measure of a figure. It's how much space is inside of the shape. All right, and all you need to do is multiply the dimensions. Remember that the height must be perpendicular to the base, which means that it's going to form a right angle. Okay, and so the first thing I'm going to have you do up here in the box, I'm going to have you fill in the area and perimeter formulas for the given shapes. Area, we're going to go ahead and look at some word problems. What I want you to do, make sure that you make a labeled drawing for each word problem. That way you can make the problem visual, okay? And then once you've got your drawing done, we're going to do three different things. The first thing we're going to do is use the correct formula. After we choose the correct formula, we're going to substitute in the values that were given. And then the third thing that we're going to do, we're going to write out what our answer is. And so in our first problem, we're told that a garden is a square measuring 11 feet on each side. I want to know what the area is. So I'm going to start by drawing a picture of a square, and I'm told that it's 11 feet on each side. So it has a base of 11 feet, it has a height of 11 feet, and I'm going to put these little markings that indicate that each side is the same length. Okay, every side is 11 feet. And I'm trying to calculate the area, so I'm going to use the area formula for a square. All right, look up above if you don't remember, but it's area equals base times height. And we're going to substitute in the values for the base and the height. They're each 11 feet, so we're going to have 11 times 11. Okay, and when we do 11 times 11, we get 121, and the units are square feet. And so we can say that the area of the garden is 121 square feet. Okay. In part B, they want to know, well, if a bag of fertilizer covers 25 square feet, then how many bags are needed to cover the entire garden? And so what we're going to do, we know that one bag will cover 25 square feet, but the entire garden is 121 square feet. So we're going to take the 121 square feet, and we're going to divide that by the 25 square feet for each bag. When we do this division, we end up with 4 8400ths. So we would need 4 8400ths bags. Except you can't buy 4 8400ths bags, so 4 won't quite do the job. So this means that we're going to have to get 5 bags of fertilizer. Okay, 5 bags are needed to cover the entire garden. In example 2, we're told that John wants to put fencing around his rectangular garden. It measures a length of 6 meters and a width of 3.5 meters. How many meters of fencing does he need to buy? And so the first thing I'm going to do, I'm going to draw a picture of this problem. We said it's a rectangular garden, so I'm going to go ahead and draw a rectangle. And we're told that it has a length of 6 meters and a width of 3.5 meters. Okay, and on the rectangle, this 6 meters is the same as this 6 meters up here. This 3.5 meters is the same as this 3.5 meters over here. So I've got the markings indicating which sides are the same. Okay, and we're putting fencing around the garden. The fencing is going to go here around the garden. So this must be a perimeter problem. Okay, and so when we find the perimeter of a rectangle, well, all you need to do is figure out what all the sides are and then add them all together. So in this case, perimeter is going to equal 6 plus, we have another 6 meter segment up here, plus 3.5, plus we have another 3.5 meter segment here. And so I'm just going to have to add up all of those numbers. Well, when I add them together, I get a perimeter of 19 meters. So we're going to say that John needs 19 meters of fencing. John needs 19 meters of fencing. Okay, so now underneath that part B, they said, how much will it cost him if the price is $24.50 per meter? Well, it's $24.50 for 1 meter, He needs 19 meters of fencing, so we're going to go ahead and multiply by 19, which gives you 465 and 5/10. This means that the fencing will cost $465.50. Okay, the fencing will cost $465.50. In example 3, they want to know how many square feet of vinyl floor covering are needed to cover a floor that measures 60 feet by 12 feet. 60 feet by 12 feet, well, that indicates to me that I must have a rectangular floor. So I'm going to go ahead and draw a rectangle. Okay, and I'm going to make it 60 feet by 12 feet. Okay, and this 60 foot is the same as this one here. This 12 foot is the same as this one here. Okay, so I've got my rectangle drawn here, and now I need to figure out how many square feet of vinyl flooring are needed to cover the flooring. Well, there's a couple of hints here that let me know that this is actually an area problem. First of all, the floor is going to cover this entire space right in here. So this is where the flooring goes, which is inside of my rectangle. Also, they say how many square feet of flooring. Square feet, well, I must be dealing with area if my units have been squared. So I'm going to find the area of this rectangle. Start with the formula, area equals base times height. Now we're going to substitute in our given values. We have a base here of 60, a height here of 12. Area equals 60 times 12. And now if we multiply those together, we're going to get an answer of 720 square feet. Okay, so you need 720 square feet of flooring. Okay, so part B says, how much will the flooring cost if it's $9.50 per square yard? Okay, don't get tricked here. Okay, it's $9.50 per square yard, but we just figured out the square feet of flooring that we need. And so what we're going to do, we're going to redraw our picture that we drew up above. I'm going to draw the same rectangle. Okay, except now, instead of using my dimensions as feet, I'm going to convert them into yards. And it's important to remember that 1 yard is equal to 3 feet. Okay, so I'm going to convert my feet into yards. I'll start with the 12 feet. Okay, I have 12 feet for this segment right here. Well, if 3 feet equals 1 yard, that must mean that this 12 feet is going to have to equal 4 yards. So this 12 feet segment is now converted into 4 yards. All right, 12 divided by 3 is equal to 4. I'm going to do the same thing with my 60 feet. Again, 1 yard is 3 feet. 60 feet, well, if I do 60 divided by 3, that's going to equal 20 yards. Okay, so this rectangle, 60 feet by 12 feet, is the same as 20 yards by 4 yards. And now I'm going to recalculate the area in yards. Area equals base times height. And now the base is 20 yards and the height is 4 yards. 20 times 4 means that we need 80 square yards. Well, now I can figure out the cost because it's $9.50 per square yard. $9.50 times 80, well, that's going to give me a price of $760. The flooring will cost $760. Example 4, they tell us to find the value of A if the perimeter of the triangle is 56 inches. Remember, for perimeter, you have to add up all of the sides. So the sides are labeled A, 3A minus 1, and 2A plus 3. I'm going to add all of those together. A plus 3A minus 1 plus 2A plus 3. And they told me that when I add all these together, the perimeter is 56 inches. So I've got this nice equation here, and I can simplify this so that I could eventually figure out what the value of A is going to be. So I'm going to just rearrange my terms. A plus 3A plus 2A minus 1 plus 3 equals 56. And now I can combine my similar terms. A, which is the same as 1A. 1A plus 3A is 4A. 4A plus 2A is 6A. And then negative 1 plus 3 is positive 2. 6A plus 2 equals 56. And now this is just a two-step algebra equation. I've got to get my 6a all alone, so I'm going to subtract 2 from each side. That means that 6a equals 54. But I want to get the value of 1a, so I'm going to now divide each side by 6. And this gives me a value a equal to 9. The value of a in this problem is 9. Now I'm going to use this answer to figure out the lengths of the three sides. My three sides again were a, 3a minus 1, and 2a plus 3. And the way that I'm going to figure out the lengths of these three sides is if I substitute in the value of a. A again is equal to 9. Well, this first one's very simple. This first side then must just be 9 inches if a equals 9. For the second one, 3a minus 1 is going to become 3 times 9 minus 1. 3 times 9 is 27 minus 1. This next must be 26 inches. And then the last one, 2a plus 3, becomes 2 times 9 plus 3. 2 times 9 is 18. 18 plus 3, the last one must be 21 inches. So these must be my three side lengths, and I can check it very easily. Remember, they said up here that the perimeter is 56 inches. So if I add these three numbers together, 9 plus 26 plus 21, it should equal 56. Well, 9 plus 26 is 35. And then if I add 35 and 21, well, I do get 56. 56 equals 56, so I know my measurements are accurate. In our last problem, we're told that a dog is tied with a rope to a stake in the ground. So there's some sort of a wood stake in the ground, and the dog has a leash, and it's tied to that stake in the ground, so it won't run away. The length of the rope is 5 yards. I want to know what's the area in which the dog can roam around your answer to the nearest hundredth. Nearest thousandth. So what I'm going to do, I'm going to draw a picture so I can visualize what's happening here. So if I imagine I've got some wooden stake here in the ground, okay, and the dog is on a leash that's 5 yards long. So the dog, if this is the stake in the ground, the dog could go 5 yards in this direction, or maybe it can go 5 yards in this direction, or maybe it can go 5 yards over here, or 5 yards over here, or 5 yards over here. You kind of get the point of what I'm saying. The dog can go 5 yards in any direction from where this stake is located. So if I connect all of these endpoints, well, you can kind of see here by my rough drawing that the dog can go anywhere in this circular spot. All right, the dog can go anywhere in this circle. So what I must be finding is the area of a circle. So I'm going to use my formula, a equals pi r squared. I need to know the radius of my circle. Unfortunately, I do. I know from the stake, which is the center, all the way out to as far as the dog could go is a length of 5 yards. And so this is actually a radius here of 5 yards, and this radius, all these different radii, they're all 5 yards. So I'm going to substitute in the value of 5 for the radius. A equals pi times 5 squared. And now I'll use my order of operations. I'll square the 5. 5 squared is 25. So this is equal to 25 pi. And now I'll use my calculator. I'll punch this in, 25 times pi. And I'm going to write out the full calculator display. 78 and 5398 1634. And now back up here it says to round your answer to the nearest thousandth. Well, right now it looks like 539 thousandths. There's an 8 here in the 10,000th spot, which is enough to round us up. So the area is approximately 78 and 540 thousandths square yards. And that would be the area in which the dog could roam in this circle.